Okay, so you're gonna have this formula. So the formula says this is called a sum of the cube. There is a difference of a cube, which is gonna be a minus b times a squared. What's the next sign? Plus ab plus b squared. Does that make sense? So that is the formula we're going to be using because this is a minus sign. So what we're going to do is that's equal to, now people make mistakes right here. First 3x minus 2, nobody make mistake on this one. People make mistakes right here. 3x squared at minus 3x times 2 and plus 2 squared. So this is plus, sorry. And then you should do it properly. So it'd be 3x minus 2, 9x squared plus 6x plus 4. And that will be the final answer to factor this. You guys want to try one more? 125x to the cube minus 1. But you do have to memorize the formula tomorrow for sum and difference of the cube. Actually, I'll give you a plus because you already did the minus. I already showed you example minus. I didn't show you example plus.
125.
Yep, 125x to the cube plus 1. The best thing is you know all the perfect cube. So for example, 3 to the cube, 2 to the cube, 4 to the cube. It helps you. Andrew, how's the nap? Tired. First period math. You guys are not smart to take first period math. Andrew's falling asleep back there. You are quick. You like math?
Yeah.
Yes. Which one? For this one, it's minus. It's the same sign. It's a minus b. We follow this formula. Huh? B is actually positive too because we follow the negative formula, so we just keep a b. At first, I write it wrong, so BQ is actually 8, so b is equal to 2. Why are you late? Why are you late?
My car broke down this morning.
Is everything okay? Is everything okay?
Well, yeah, the battery was like.
Okay. All right, so if you do it properly, it's going to be 5x plus 1 because that's a and b. And this is 25x squared, not 5x squared. Most people make mistake is 5x squared because of the whole thing square. Minus what? 5x plus 1. And that's how to factor sum and difference of a cube. And just simple question like this tomorrow, just fact sum and difference of the cube. If you two see 27, 8, 125, 64, they all cube. You have to know all the perfect square, you have to know all the perfect cube because sometimes people try to do difference of a square here, but they are not square. Got it? Okay. Binomial expansion. Now I'm going to send you a video to watch. I personally love binomial expansion. The reason why I like binomial expansion, there's actually a lot of math to it, and I don't have time to get to it. But there is a lot of math developed everywhere in the world, start from the history. People in China, people in India, people in Syria, people in, I don't know, Iran. It's in Iran, they call it Mount Meru's staircase, Mount Meru stair. In China, it's called Yanghui Triangle. In Europe, is known as a Pascal triangle. A Pascal triangle is a very interesting pattern. For example, I'm gonna show you what a Pascal triangle, how to build them. First, you start with a 1. And you think about it, there was a 0 next to it. It's like invisible 0, right? But you don't need to worry about that. Now, this 2 number is going to form another 1. And this 2 number is going to form another 1. Does that make sense? You add 0 plus 1, that's going to be 1. And you can have 0 here. This 0 is invisible. But however, here is going to give you 2. And here is going to give you 1. Does that make sense? You just keep on adding previous numbers. So this 2, and this 2, and this 2, right? And you place a 0 here, right? But normally you don't need to do that 0. Normally I just do that 1, 1, 1, 2, 1. So this is going to be 0 here, and that's going to be 1, sorry, 1, 3, 3, 1. Now I'm going to keep on going now without that 0. 4, 6, 4, 1. You got this? In Davy, you probably did this last year too, right? No? Okay, so now you're the first time. 1, 5, what? 10, what? 10, and what? 5, and 1. So it turns out that there's a lot of special thing about these things. So if you look at like pattern, right? So pattern is going to give you a 11 to the 0 power is equal to 1. 11 to the first power is equal to 11. 11 to the second power is 121. 11 to the third power is 1331. Next one is 11 to the fourth power. It actually has a special pattern. Now, sometimes you can also look at this particular place right here, 1, 3, 6, 10. That's also another pattern-based building a triangle with the circles. So that just say the first part you're building a triangle. And that's 1. The triangle is going to be the next one. The next layer is going to be what? 3, right? The next layer is going to be what? No. Can you count? 1, 2, 3, 4, 5, 6. Do you see that 6? Is what? 10. You see 1, 3, 6, 10. But you see this number 1, 4, 10. That's another layer, but it's in 3-dimensional. Just think about if you have circles. If you have 1 on the top, you must have how many on the bottom? 3 to build a 3-dimensional shapes, right? 1 circle on the top, 3 circle on the bottom. You can stick a 1 circle on the top. So that's 1 plus 3 is equal to 4. And the next layer is going to be more circle on the bottom in order to build up that pyramid. And so there's a lot of things. You can also form, so you're going to watch this video to look like that. Now, video I will send on group chat is very interesting, but I'm not going to talk about it. So I can do this. Let's say, oops. Let's say a plus b to the 4th power. Okay, to the 4th power. Now, if you want to expand them normally, it's going to be a lot of work. Now, the best thing is, it's not a lot of work. You're going to take this, 1, 4, 6, 4, 1. You're going to take a coefficient. And what you're going to do is you're going to do a to the 4th power, b to the 0. Just like you can imagine you have 4 kids, and 4 of them are all boys and 0 girls. What's the next possibility it's going to have? A to the what? No. Do you only have 4 kids?
4 or 3 and 1.
3 and 1. Good. You have 3 boys and 1 girl. And you have what? Now what's the next one? 2 and 2. And what's the next one? Sorry. 1 and 3. And what's the last one? 4. Yeah. So you can say that's 1a to the 4th plus 4a to the 3b plus 6a squared b squared plus 4ab to the 3rd minus b to the 4th plus. And that's called a binomial expansion. You just expand this rather than doing this 4 times, which just take you forever to do because you had to expand those 2 and you had to expand those 2 and then you have a 3 term and you had to expand everything. That's a lot of work. So if I were you, I'll pick a smarter way to do it. I'm going to show you. That says 2x minus 1 to the which power? Give me a number. 5 is a lot. All right. Let's just do 3 for now. Because I don't feel like going too much. Because we don't have much time. So 3, we're going to use this layer with the 3. So you're going to write down number 1, 3, 3, 1. Is that okay? What is a in this case? B is what? Negative 1. Good. So it'll be 2x to the which power? To the what? 3rd is correct. And negative 1 to the which power? 0. Right? Plus 2x to the 2nd power, negative 1 to the 1st. Right? And to the 2x to the which power? Not 3rd. 1st. And negative 1 to the what? 2nd. And plus negative 1 to the what? 3rd. Okay. Anything to the 0 power is 1. So that's going to give you ax cubed. Plus 3 times 2x squared and negative 1. So that becomes this is negative. So 3 times 4 is what? 12x squared. Does that make sense?
Why is it negative?
Because it's negative 1 to the 1st power. And there's a negative 1 to the 2nd power that makes positive. So that this one is going to be 6x and negative 1. And just expand this without doing too much work. It's a negative 1 to the 3rd.
Also the last part.
Yeah, so it's negative 1 times negative 1 times negative 1. So it's negative 1 to the 3rd. You guys got... I'm going to do it to the 4th power, okay? Normally, you're going to expand 3x minus 2 to the 4th power. It probably takes about 7 to 8 minutes. And hopefully it doesn't make mistake. With binomial expansion, you can probably do it in 2 minutes. So try binomial expansion, very powerful tool. I'm gonna send you a video talk about patterns. There was Sapensky's triangle. If you're a big fan of Veritasium, they actually talk about the Pascal triangle on the negative sides, even on the decimal size, fractions. But I'm a big fan of Veritasium. I don't know if you've ever seen his video. It's like Mark Gruber, but he's more sciencey instead of engineering. It talks about a lot of cool stuff. One of my favorite channel on YouTube. Let's talk about knowledge rather than roadblock. Since I don't have much time, I'm gonna write down all the coefficients. So 1, 4, 6, 4, 1. And I'm gonna write down the pattern. So it'll be 3x to the 4th, 3x to the 2nd. Oh, sorry, third. 3x to the 2nd, 3x to the 1, and 3x to the 0, which is 1. And then this is going to be -2 to the 0 plus -2 to the 1st plus -2 to the 2nd plus times -2 to the 3rd times -2 to the 4th. I will finish this video. You guys can watch it. But this one's going to give you 81x to the 4th plus or minus 27 times 4 is 108. It's 216x to the 3rd. And this is going to be plus 4 times 6 is 24. 24 times 3 is 72. And that's going to be -8. 8 times 12, I believe, is 96x plus 16. Enough?
I have two questions. One makes my second question is you release work during your planning period, right?
Usually, like after school planning period, if I can planning period, but mostly after school.
Which period is your planning period?
My parents 5th, but I sometimes I release after school, so usually I release before 3.
Well, I have to take tests tomorrow because I was here like 4 days.
That's fine. You can wait a little bit, but you still have to go back to understand all your homework and understand come to tutoring. And so the first week we just talk about fraction, addition, subtraction, multiplication, division. I don't know, a lot of stuff. So.